All right, I got my lights on, which you would know from the last video. It was getting real dark and it was just, I was too involved to turn the lights on. I got some more Diet Coke. All right, we're in business. All righty, 11.7, it's our last section, y'all. I hope you're not sad. I hope you're very relieved and feel very educated. That's my goal, is to make sure you leave smarter than you walked in. All right, so 11.7 is plane curves and parametric equations. I don't want you to get freaked out by the amount of words that are in this worksheet, okay? It's very wordy. There's a lot of explaining at first, but then once you get into this, this is not terribly difficult at all. It's actually a kind of a nice way to end this course, okay? So we have one, two, three, four. Lord have mercy. We have six topics, okay? A few of them are just kind of like background information, and then a few of them actually have problems that we have to work. So let's just kind of dive in. So topic one is like, what is a plane curve? Okay, the name of this section is plane curves and parametric equations. So let's kind of dive into this idea of plane curves. And you know how much I love a good definition. Okay, so definition, a plane curve, plane like as in a two-dimensional plane. A plane curve is a plane that lies entirely within a two-dimensional plane, meaning it is the set of all points x, y in the coordinate plane that satisfy a particular relationship which can be expressed in different ways. Okay, we deal with plane curves all the time. Okay, so we kind of have three different ways that we can represent these plane curves, and I do want to go through them kind of quickly. I don't want to get too lost in all the words, but I do want to explain this. You can represent a plane curve in what we call kind of like an explicit way. So you can explicitly represent a plane curve, and that just means you have solved for y. Okay, so we could have something like y equals f of x. Okay, it means you've isolated y on one side of the equation. You have a function where y depends directly on x. Okay, and then finally, we have an example would be the equation y equals 2x plus 3. Okay, y equals x squared minus 5x plus 2. Those would be equations in explicit form. Okay, now you could represent some kind of plane curve implicitly, and this just means the notation here is a little weird. It says we have f of x comma y equals 0. It just means you haven't isolated the y. Okay, so meaning I is not isolated and often defines a curve that cannot be written as a function. It doesn't mean it has to be something that cannot be written as a function, but you're generally going to be dealing with something that can't be written as a function. Okay, can you write stuff that is in an implicit form in explicit form? Yes. Sometimes it's beautiful. Sometimes it can get a little nasty. Okay, but you could. All right. We know that there is a relationship between X and Y. Okay, so great, wonderful. What does that mean? Well, an example of this would be something like a circle. A lot of times we will write a circle in what we call standard or general form. Okay, and notice we haven't solved for Y. We have X squared plus Y squared equals 25. This is a circle centered at the origin with a radius of 5. If we were to solve this for Y, we could. It wouldn't be cute though. We would get Y equals plus or minus the square root of 25 minus x squared. That's nasty. Okay, so we could write it solve for y, but it isn't always going to be a pretty thing. So again, a lot of times the implicit form is for stuff that can't be written as a fraction, and if you write it explicitly, it's not as pretty sometimes. Not always, but sometimes. And then finally, we have the form that's really going to entice us. You can write these plane curves parametrically. So basically what we do is we kind of rewrite the equation as two separate equations, one for x and one for y, based entirely on a third variable, generally t. Okay, so parametrically we would have something like, excuse me, I got something in my eye. We would write something like x equals f of t and y equals g of t, where t is this third variable. Okay, now t is generally what we use. It doesn't necessarily have to be t, but we generally use t, and t typically, not always, but a lot of times we'll let it refer to like time. Okay, so what this means is both x and y are defined in terms of a third variable, t. Okay, usually t, generally meaning time. It doesn't have to be time, and even if it is time, we can get kind of like a little loose with the meaning of time. It's used when a curve cannot easily be described using just x and y, or sometimes you'll use this when modeling motion. Imagine a particle moving along a pathway, okay? An example would be something like x of t equals 3 cosine t, and y of t equals 3 sine of t, which traces a circle with a radius of 3. Okay, and we'll see something similar to that much later in this worksheet. Okay, so that's what a plane curve is. It's just a curve. Okay, it doesn't have to don't think like a literal curve like a curve in the road. It's just something that we can graph in a two-dimensional, like XY coordinate plane is what we're typically familiar with. So think of anything you can graph in 2 dimensions, that would be a plane curve. Okay. So again, explicitly written, implicitly written, or parametrically. Okay. So that's just an introduction to plane curves. In the next video, we will talk about, okay, what are these parametric equations? We'll go much deeper into that. We'll look at some examples, and then we will do more and more and more until finally, we get to our last video.